System of circles. Now we discuss about the system of circles. We have already discussed about circles and its various properties. Now comes the question on discussing on the system of circles. What do we mean by system of circles? The system is nothing but a group of circles which we take together. Say for example, if I have is equal to C. This is as similar as what we have taken in the form of x square plus y square equal to r square. If I assume the radius to be a C, a constant, then we get a system of circles. That is, if I take C with different values, if I take C belonging to all real numbers, for every C belonging to the real number, we get a different circle. Say for example, C equals to 1 implies x squared plus y squared equals 1 square, and C equals to 2 implies x squared plus y squared equals to 2 square is how we get the derivation. Similarly, C equals 100 implies x squared plus y squared is 100 square, and etc. This makes us understand that for different values of C belonging to the set of real numbers, we get different types of equations. These together form the system of circles with a fixed C belonging to R. That is, if I take, say for example, the first circle x squared plus y squared equal to 1, then this is a circle with radius 1. Next, if I take x squared plus y squared equal to 2 square, it's a unit circle with radius 2 and center origin is what we get. And similarly, if I go on, I get a circle with radius 100. So these set of circles together, the concentric circles, form the system. The whole of the circles form the system with the common equation x squared plus y squared equals to c squared. So such type of equations, which are generally represented with a constant or a parameter c belonging to real numbers, is said to be the system of circles. The value of c defines the whole system of circles. With c equal to 1, I get the initial circle, and c equal to 2, I get this, etc. and etc. When c is 100, I get a circle, which all this system is the concentric circles which you see in this xy coordinate system, and whole system depends on C. This is how we define the system of circles, taken with this example. Now next is the concept of angle between the circles. Now initially we have seen that we have the angle between two lines, which we all know as, if I have two lines which are intersecting, then the angle between the lines is either this or this, or this and this is equal, is this, is how we define the angle between the two lines. So similarly, the two circles are said to have some angle between them, provided the two circles are intersecting. So here the important factor is that angle depends on intersecting circles. If the two circles are not intersecting, then we don't have angle between them, because they are simply far apart from each other. So angle is related to the intersecting circles in the way that, if suppose I have two circles then angle between the circles is nothing but the angle between the tangents. That is, if I have the two circles intersecting here, this point of intersection, if I denote with P, has two tangents, one to circle with C1 and one to the circle with center C2. So if I have a tangent drawn here, which is T1 to this circle, and there's another tangent which is drawn out here for the second circle, which is T2, then angle between two circles is nothing but angle between their tangents. This is said to be the angle between the two tangents. It is very important to note that angle between two circles is angle between their tangents at the point of intersection. Is very important note out here which we need to make. Angle between two circles is angle between the tangents at the point of intersection. An angle exists only for intersecting circles. Is how we understand. So here theta is the angle between T1 and T2. Is how we understand the angle for intersecting circles. Next, now that we have discussed about the angle between two circles, the biggest question which comes out here is that if suppose I have two intersecting circles, this is with center C1 and this is with center C2, and suppose the two circles intersect at P and Q, for these two intersecting circles which intersect at P and Q, now that we have defined the angle between two circles as angle between the tangents T1 and T2. Now similarly, I have the other point of intersection where I have the angle which can be formed if I take a tangent from here and then from here, so that I denote this with T3 and T4. So if I take angle between T1 and T2 is theta 1, and if I take the angle between T3 and T4 at the point of intersection Q as theta 2, then geometrically it is a fact that theta 1 will be equal to theta 2. That is, for both the points of intersections, the angle between the two circles is either the angle here or the angle here, because both the angles are equal geometrically. So the angle between two circles is the angle between the tangents drawn at the point of intersection either at P or at Q, because theta 1 being equal to theta 2 geometrically. So I have S equals x square plus y square plus 2gx plus 2fy plus c equal to 0 in the general form, and I have the other circle denoted by S dash, that is x square plus y square plus 2g dash x plus 2f dash y plus c dash equals 0. So for these two circles, if I would like to find the angle between the circles in the general form, I have cos theta given by c plus c dash minus 2gg dash minus 2f f dash whole by root of 2 times of root this and g dash square plus f dash square minus c dash is how we get the angle between the two circles in general form, given by this formula. Orthogonal circles. So what do we mean by orthogonal circles? The word orthogonal is referred to be perpendicular. Is referred with 90 degrees. Therefore, if the angle between the two circles is 90 degrees, we say that the two circles are orthogonal, because 90 degrees is very much associated with orthogonal. So orthogonal circles are the circles which cut at 90 degrees. That is, if I have the angle between the tangents T1 and T2 to be 90, that is, if T1 is perpendicular to T2, implies the two circles, of course, which are intersecting are orthogonal, and the angle would be 90 degrees. For condition for orthogonal circles is angle equals 90 degrees. Now let's see the condition for orthogonality. When do we say the two circles are orthogonal in the mathematical sense of connecting with orthogonality? Suppose I have two circles and the distance between their centers is D, and the radius of the first circle is R1 and the radius of the second circle is R2, then we have seen the angle between the two circles, which is theta, is given by cos theta equals d square minus r1 square minus r2 square by 2r1 r2. So this was the formula which we already discussed in finding the angle between two circles. Now, since for orthogonality we know that for orthogonality theta is obviously 90 degrees, because the condition for orthogonality is that the angle is 90, and using theta equal to 90, let's see what the formula reduces to. So with theta equal to 90, substituting in this, I get cos 90 equals d square minus r1 square minus r2 square by 2r1 r2, where cos 90 is 0. So therefore, cos 90 equal to 0 implies this equals minus r1 square minus this of this, with cos 90 equal to 0. Now this reduces equal to 0 with this multiplied with 0. That implies d square is the condition for orthogonality of two circles. The square of the distance between the centers of two circles is equal to sum of the squares of each of the radii, or the radii of each of the circles, is how we define the condition for orthogonality of two circles defined here. Now let's find the condition for orthogonality for general form of circles. That is, if the two circles are given in the form of x square plus y square plus 2gx plus 2fy plus c equals 0, and s dash is x square plus y square plus 2g dash x plus 2f dash y plus c dash equals 0, then in this case we need to find the condition for orthogonality for these two types of general form of circles. So as we know that angle between the two circles in general form is given by cos theta equals c plus c dash minus 2dg dash minus 2f f dash by 2 root minus c dash. Then we know that for orthogonality theta is 90 degrees. When I substitute theta equal to 90 degrees in this, that implies cos 90 is equal to c plus c dash plus 2dd dash 2f f dash by 2 root g square plus f square minus c g dash square plus f dash square minus c dash is what we get, which on further simplification gives us cos 90, which is 0, and then c plus c dash minus 2dg dash minus 2f f dash by 2 root g square plus f square minus c root g dash square plus f dash square minus c dash, because cos 90 is 0. Now this, when I cross multiply, gives me c plus c dash minus 2dg dash 2f f dash equals 0, which on final simplification gives is equals to c plus c dash. The condition for orthogonality for the circles in general form is given by 2gg dash plus 2f f dash equal to c plus c dash. gfc and g dash f dash c dash derived from the two circles in general form. Now let's discuss the geometrical properties involving the orthogonal circles. If suppose the two circles are orthogonal, the circle this and the circle this, with center C1 and center C2. Now if suppose the two circles are orthogonal, then we say that the tangent to the circle C2, say this is T2, and the tangent to the circle C1 T2 will pass through the centers. That is, if the two circles are orthogonal, then the tangent of, say, circle 1 passes through the center of circle with center C2, and the tangent at circle C2 passes through the center of this circle. Geometrically, this is true if the two circles are orthogonal. So, tangent of circle C1 passes through center of circle C2, and next tangent of circle C2 passes through center of circle C1. As can be clearly seen, the tangent of circle C1 is passing through the center of circle C2, and tangent of circle C2 is passing through center of circle C1. This is the geometrical property, and tangent of circle C2 passes through center of circle C1 is how we understand the geometrical properties connecting the orthogonal circles. Now this is the true case only when the two circles are orthogonal. If these two circles do not cut each other at 90 degrees, then we cannot have a tangent passing through the center of the either circles. This is how we understand the geometrical property connected with orthogonality of circles. Common chord, as we know, is the chord for both the circles. So if I have two intersecting circles, then this is the common chord of the two circles. A, B is the common chord. Now for this common chord of the two circles, where if I represent this circle with S equal to 0 and this with S dash equal to 0, then equation of common chord AB is given by directly with the formula S minus S dash equals 0. So equation of common chord is obtained by just subtracting S dash from S. This is how we understand the equation of common chord AB. S minus S dash equal to 0. Or even this can also be written as S dash minus S equal to 0. Both give the same equation of common chord. S minus S dash equal to 0 or S dash minus S equal to 0. Common tangent. Now let's see the equation of common tangent. As we all know what a common tangent is. A tangent which acts for both the two circles is what is a common tangent. Now if I have, say, two touching circles, this given by equation S equal to 0 and this given by the equation S dash equal to 0, then this is the common tangent between the two circles. That is, T acts as the common tangent to the two circles. Then how do we find the equation of T is the biggest question here. The formula for finding equation of common tangent T is we have S minus S dash equal to 0 is the equation of common tangent, which is given by S minus S dash equal to 0, or this can also be given as S dash minus S equals 0. Is how we understand the equation of common tangent for the two circles. Now there's other possibility that I have the two circles touching internally. Then in this case I have the common tangent this. So this also is given by the equation S minus S dash equal to 0. So let me have a circle in general form as S equals x square plus y square plus 2gx plus 2fy plus c equal to 0, and let me have a line L given by lx plus my plus n equals 0. Now with this basic information of a circle and a line, if I say that there is a circle and there is a line which intersects the circle at here, so this is the circle and this is the line which intersect at 2 points, say A and B. So if I have a condition where a line is intersecting the circle forming a chord, then in this case, the equation we have system of circles, which we have taken as the heading. The introduction of system of circles is very important, because when we discuss about these kind of situations where a line intersects a circle, there are system of circles which can be formed using this chord AB. So initially, if I want to find the equation of a circle passing through AB, say for example, I want to find equation of a circle passing through this chord AB, or I want to find another equation which is like this. So like this, we have different types of circles which can be formed using AB as the chord. So one of the circle is this, one is this. There might be one more circle which can be formed like this. Etc. So we have system of infinitely many circles which can be formed from the chord AB. So this infinitely many circles form a system which you're going to see as a formula. Therefore, equation of the system of circles passing through A and B, that is, the points of intersection of the line in the circle, which is A and B, passing through A and B, equations of the system of circles passing through the points of intersections A and B is given by S plus lambda L equals 0, where lambda belongs to set of all real numbers, is how we understand the equation. So system of infinitely many circles which can be formed passing through A and B is given by S plus lambda L equal to 0, where lambda is a real number and this lambda is called the parameter, because this value of lambda decides what is the position of the circle which is drawn through A and B. So lambda acts as the parameter which measures the circle which is drawn through A and B. Is how we understand the system of circles S plus lambda L equal to 0, which is the equation of systems. Also, since lambda belongs to R and the set of real numbers is infinite, therefore for infinitely many real values of lambda, there are infinitely many circles which can be drawn passing through A and B. So therefore this forms an infinite system of circles. Therefore, since lambda has infinitely many values, of course belonging to R, therefore there exists infinitely many circles passing through A and B, which are the points of intersection of the line and the circle. So this plays a very important role in understanding the system of circles connected with the parameter lambda, so which states that since lambda has infinitely many values being real numbers, therefore there exist infinitely many circles passing through A and B. For each lambda there is a respective circle, and hence we form an infinitely many circles. is how we understand the concept of system of circles connected with the parameter lambda belonging to real numbers. Similarly, let's identify the system of circles for two intersecting circles. In the previous case, it was a line which was intersecting the circle, and then we got a system passing through AB. Now here, let's see if we can form a system of infinitely many circles which can be formed for two circles which intersect. So let me take the two intersecting circles. So let me say this equation of this circle is S equal to 0, and equation of this circle is S dash equal to 0. Now, if suppose the points of intersection of the two circles is say A and B, then as in the previous case, the point of intersection of a line and a circle gave A and B. In this case, two circles intersect to give the points A and B. So if I can draw infinitely many points, circles through A and B. Suppose I would like to draw a circle passing through A and B, and then I would like to draw a circle passing through A and B, and then there's another circle with bigger radius which I would like to draw passing through A and B. So that I get infinitely many circles which can be drawn through A and B, which is called the system of circles. Now, the equation of this system, equation of system of circles passing through A and B is given by lambda s plus mu s dash equal to this, where lambda mu are the real numbers such that mu plus lambda is not equal to 0. Is how we take the condition. Now the parameters here are lambda and mu, which define the system. So there are two parameters which define lambda associated with circle S equal to 0, and the parameter mu which is associated with the circle S dash equal to 0. Is how we define the system of circles for intersection of two circles S equal to 0 and S dash equal to 0. So now that we have the two parameters mu and lambda which are involved in the system of circles formed for the two intersecting circles, now next let's reduce that to a single parameter. So with the formula as we have seen here, which is lambda s plus mu s dash equal to 0, assuming that lambda is not equal to 0 implies I divide the whole equation with lambda, so that I get lambda s plus mu s dash divided with this gives me this, strictly because I assume this non-zero. So this on further simplification gives lambda s by lambda plus mu s dash by lambda equals 0. This on cancelling, since lambda is not equal to 0, I further get s plus mu by lambda of s dash equal to 0, where mu by lambda is not equal to minus 1. So let's see why this is not equal to minus 1 in the future cases. Let k equals mu by lambda, which belongs to real number, because mu is a real number and lambda is a real number. So the ratio of two real numbers, which is k, is also a real number. Therefore, this reduces to s plus ks dash equal to 0 is the new system of circles for k belonging to R, is how we understand the two parameters reduced to a single parameter k belonging to real numbers. The system of circles with single parameter k is s plus ks dash equal to 0. In the previous case, we have defined the system of circles for two intersecting circles as s plus ks dash equal to 0 with k, which is assumed as not equal to minus 1 belonging to R. So what could be the reason that k is not equal to minus 1 is the biggest question. So what if k is equal to minus 1 is the biggest question here. So in order to just investigate on why k should not be equal to minus 1, let's take the contradictory of assuming that k equal to minus 1 implies this reduces to s plus k, which is equal to minus 1 times s dash, which is equal to 0. Then in this case, I get this to be s minus s dash equal to 0. But s minus s dash is already known to be the common chord of the two circles, that is a line. A common chord is a line. Therefore, for k equal to minus 1, we get a common chord which is a line. But we want the system of circles. Therefore, we have k not equal to minus 1. Therefore, for system of circles, k is not equal to minus 1 is how we understand this concept. K equal to minus 1 implies the system reduces to this, which is the common chord or the common tangent for the two circles, and hence it reduces to a straight line, which is a contradiction. Therefore, for system of circles, k is not equal to minus 1. The limitations of k is that k is any real number except minus 1. Now let's do some problems connecting the system of circles. So in this case, we have, say for example, a problem where I want to find the equation of circle which cuts the circles x squared plus y squared minus 4x minus 6y plus 7 equal to 0, and also it cuts x squared plus y squared minus 10x minus 4y plus 21 equal to 0. So we have to find the circle which cuts this and this orthogonally. And has its diameter on the line 2x plus 3y equal to 7. So in this case, there are three conditions given: that the circle which I need to find is cutting this circle at 90 degrees, this circle also at 90 degrees, and it is having its diameter on the line 2x plus 3y equal to 7. So using the three conditions of this, this and this, I am going to find the equation of the circle. So let's see how we can find the equation of circle using the three basic conditions 1, 2 and 3. Now initially, because I don't know the equation of circle, let me take the equation of circle in general form. Let the equation of circle be S equals x squared plus y squared plus 2gx plus 2fy plus c equals 0. So this is the equation of circle in general form, which I take as equation 1. And next I take this as equation 2 and this as equation 3. So with three equations 1, 2 and 3, I use the condition that this circle is cutting this orthogonally. In general form, we have a formula or the condition for orthogonality which I am going to apply in case of this circle cutting this at 90 degrees. Similarly, this circle cutting this at 90 degrees, I get one more orthogonal condition which I am going to apply. So let's see how we can apply that. Now with the given problem, we assume that with the circles that if I would like to find the equation of the circle which cuts the circle with equation 2 and the circle with equation 3, then the circle which is cutting this orthogonally, that is at 90 degrees and at 90 degrees, then we have to find the circle which cuts this circle at 90 and this circle at 90 and has its diameter on the line 2x plus 3y equals 7. So the diameter should lie. So if I assume these conditions, then we get a picture on how we need to solve this problem. So one is, this is orthogonal to the given, to the circle we need to find, and this is orthogonal to this, and the diameter lies this on 2x plus 3y equal to 7. So using this condition, let me say S, this is the equation of circle in general form as S equal to 0, which I have taken as equation 1. Now 1 is orthogonal to 2, that is perpendicular, implies the condition is 2gg dash plus 2f dash equals c plus c dash. We have this condition in the formula. So with this condition, I have 2gg dash, that is my g is from this and my g dash is minus 2 plus 2f, f dash from here is minus 3, that is equal to c plus c dash, which is 11. This on simplification gives minus 4g minus 6f is c plus 11. This on simplification gives me 4g plus 6f plus c is negative 11. So I assume this to be equation 4. So this is equation 4, which I have obtained by taking the orthogonal condition of one orthogonal to equation 2. Similarly, the second case of one orthogonal to equation 3 gives me another condition or an equation in G, F and C. So let's go with the second case. Now similarly, 1 is orthogonal to 3 implies I get 2g, g dash in this case is half of minus 10, which is minus 5, plus 2f, f dash is half of this, which is minus 2, that is equals to c plus c dash. Now this on further simplification gives minus 10g minus 4f is c plus 21, which on further simplification gives 10G plus 4F plus C equals minus 21, which I take as equation 5. So this on simplification gives an equation in three unknowns G, F and C, that is 10G plus 4F plus C equals negative 21, which is equation 5. Now I take the third condition where the diameter lies on this line. The center lies on the diameter of the equation.